Hello, welcome to the Bioinformaticscoach channel. In today's video, I'm going to show you how you can merge multiple VCF files into a single file using bcftools. So let's get started.
This tutorial is based on a blog that Dave Tang wrote on his blog post. So I'm going to leave the link to the original post so that you can read and get the commands that are used for this tutorial. We are going to use a data set from the NHLBI exome sequencing project, and this is the page. Initially, we take into the home page, and when you come to downloads, this tab here, you click on it, you have the data here. We are using the VCF file here. This contains VCF files for the different human chromosomes, so you take note of that. In order for you to follow this tutorial, you need to make sure you have a Linux environment. If you are using Windows, you don't have to worry. I have a separate video that shows you how to set up a Linux environment in Windows, so you can watch that. The link to that video is in the description box. You also need to make sure you have installed Anaconda in that Linux environment. I have a video that shows you how to install Anaconda in Linux, and the link to that video is also in the description box. We are using Anaconda to install the tools that we are going to need, so you take note of that. We are going to install Tabix, Para, BCF tools, and then bgzip. These are the tools that we use for this tutorial. So if you have them installed already, then you don't have to install Anaconda for that. So you take note of that. So let's go to the terminal and then proceed. So I'm on my terminal. So the first thing we have to do is to add Conda channels. That is assuming you have installed Anaconda on your system. So let's do that first. We are adding two channels, BioConda and then Conda Forge. So we see Conda config, add channels. We add BioConda. Let's add a second channel, which is Conda Forge. Let's confirm that the channels have been added. So we see Conda config, show channels. So we have the two channels here. The default one comes packaged with Anaconda, so we leave it as it is. Now we are going to create an environment and then we install the tools we need in that environment. So let me show you how. So you see Conda creates -n. We give the environment name, let's say VCF merge. Then we list the tools we are going to install. We have Para, we have Tabix, we have VCF tools. bgzip is installed when we are installing Tabix and then VCF tools. So you don't need to add that one here. So we take it as it is. So let's run and install the tools now. Okay, so we need to confirm. So we type Y, hit enter, and then the packages will be downloaded and installed for us. So let's wait for it to be done. Okay, so we have the tools installed for us, so that's great. Let's clear the screen first. Now we are going to test the tools that we installed, and to do that we need to first activate the environment. So we say Conda activate VCF merge. So we have activated that environment. So let's just test. Let's say bgzip. We are just testing one of them. Yeah, so we have it installed. So I assume that all the others have also been installed successfully for us. So we are good to go. So the next thing to do is to download the dataset. So let's go back to that page where we had the data. So we are going to use the datasets. So now with the download, you can use whatever approach you want, but I'm going to do it on the command line. So I'll use wget to do it. So I'll need to first get a link. I'll copy this link here, the download link for this file, this very one here. Let me do it again for you. Copy the link. And I'll go to my terminal and then use it there. But you can also download from your browser and then get it there. The most important thing to do is to make sure you have the data downloaded. So I'll use wget and then supply it with a link here. You can also use curl to do it or other downloaders as well. If you're using Mac OS, you can still install wget and then curl and use them to download. So I'm using Ubuntu. So we have it here, so I'll run it to download the data. So let's wait for the data to download. Okay, so we have it there. Let's do an ls. So there's the data we downloaded. Okay, so this is a tar.ball file. It contains VCF files for the different chromosomes. Let's clear the screen first again. So what we are going to do is to first extract the contents. So we say tar xvfz and we specify the name and then we extract. So we have all the VCF files being extracted for us. So they are done. Let's clear the screen again. So we have the VCFs extracted for us. So let's do an ls. And when we do ls, you notice that we have them here. All the .vcfs are here. All those which are in white, they are the ones that were extracted. This is the original file that we downloaded from the internet. Okay, so what we are going to do is to organize the files. So we are going to create a directory and then put the VCF files that were extracted into that directory. So you say make the all VCFs. And then we are going to move the VCF files we extracted. So let's do an ls again. So these are the VCF files that we extracted. This is the directory we created. So that's what we are going to do. So we say move star.vcf and we put them in the all VCFs directory. So now if you do an ls, you realize we don't see the files there again. We only see this and then my desktop here and the directory that we created here. So let's do an ls in that directory, all VCFs, and then you see that we have the files here. So we are going to cd, let's clear the screen first. We are going to cd or change and move into that directory that has the VCF files. So we say cd all VCFs. Let's do an ls again. We have everything we need here. Perfect. Let's even check how many files are there. So we say ls star.vcf pipe wc-l. We have 24 VCF files there. So what we are going to do is to first compress the VCF files. We need to compress it and then we continue. So we are going to compress all the 24 VCF files. We are going to use bgzip. But then because we have multiple files, we want to make it faster by using parallel as well. So parallel will ensure that the task is split and then distributed among the CPUs or processors on your system. That makes it faster. So we say parallel bgzip and we give this 3 colons and we say star.vcf. So star here means all files ending with .vcf. So let's do the parallel. Okay, so the files have been compressed. Let's do an ls. So you notice what we have here now. Formerly it was .vcf, but now it's .gz because we have compressed it. So that's what we need. The next thing to do is to index these VCF files, the ones that we compressed. So we are going to use tabx to do that. Again, we are going to speed it up by using para. So we say para tabx-p, which is here, -p, and then we indicate VCF, and then we say we add our 3 colons and we say star.vcf.gz. That's what we have here. So what we are doing is to specify this, and then we now do the indexing. So we run this command. Okay, so that has also been done. So if you do an ls, you notice we have some other files generated, those that are ending with .gz.cbi, and we have our files here, the compressed ones here. So let's do a sanity check here to make sure that the compressed files all have their corresponding indexes. So we are just going to do a count. So we say ls star.vcf.gz.vc-l. We have 24. Let's do same for this one here. We have 24. So everything is in order. So that one is done. So now we need to do the merging, and here we use bcftools to do the merging. So what we are going to do is this. So we are going to say bcftools, we add merge, and we say -o to specify the file name. So let's say, let's use all here, all VCFs. Okay, that's what we are going to, just to make sure we have it there. Or let's just make it this way. Let's say merged VCFs. That would be better. Let's put it this way. So, and then we add our extension .vcf.gz. So that will differentiate between the other ones here for us. So this is where we do our merging. It's VCF. Yeah, so let me correct that. So that's what we have here, and then we specify this -o z. So -o z here indicates that we want it to be compressed as well, and that is why we have it there. So let's do it this way. We say star.vcf.gz, and now the command is complete. So again, we have bcftools to merge. Output file is what? Merged vcf.vcf.gz. -o here, capital O here, z means bcftools should compress it, just as we did earlier on. And that is what we have here. So this file here will be also generated in the same directory. So let's do it that way. So we do the merging here now. So we wait for the merging to complete, and then we continue. And please know that depending on your computing or your hardware power, the merging might take some time. So you make sure you are patient and you wait for it to be done. Okay, so we have the files merged for us. So if you do an ls now, you see it here. There's it. You can also do ls just to get the name also here, and then it shows it for you. So you have done the merging successfully. So that is how we do the merging here. Let's clear the screen and then go to the next activity. So now we are done with the merging of the files. So what we are going to do is to do the topics. We are going to do the indexing as well. So the indexing, we say topics -p VCF, and then we specify the name of the merged data, which is this one, and then we index. So we do it here. So we wait for the indexing of the VCF to also be done. So now it's done. So let's do ls, and you will see that it is also here for us. So that is how we do it for this one. So this is how we do the merging of several VCFs into a single file using the BCF tools. So you take note of that. Now, once we are done with this, it's important you do some sanity checks to just compare the number of variants in the original individual VCF files and then the merged VCF file. But this is something I want you to do on your own, following the tutorial on the Thanks blog post. So please visit that link and then do that as well. So that will be all for this tutorial, and I'll see you in the next session. Goodbye.